So we have talked about the ring counter in the previous class also, to give you guys a brief idea. So it is basically a shift register, a right shift register, and the output is connected with the input. So as a result, it will look something like the value is shifting from one end to the another, and it is like rotating. Okay, so let me give you a good view of this picture right here. Can you hear me properly? Am I audible,
Yes, sir.
guys? Okay, so let me show you a example of a ring counter so that you can understand it properly. So hopefully you are seeing the picture right here, or seeing the circuit right here. Can you see the circuit? Anyone? Can you see the circuit right here?
Yes, sir.
Okay, fine. So let me give you a good example. So see that in the last class we have talked about that the ring counter can be made using the shift register technique. You can see this is a 4-bit shift register. The Q is connected with D. All the Qs are connected with D. And to make it a ring counter, the last bit right here, the output of the last flip-flop is connected with the input of the first flip-flop. You can easily see that, right? So this is my 4-bit ring counter. So this actually is, sorry, not this one. This actually is this circuit right here. You can see that one minute. Okay, this one right here, the one at the top. And you can also make a 4-bit shift register by using a 2-bit counter and a 2 to 4 decoder. That is also at the bottom. This is the circuit right here. You can easily see this is a counter. Actually, this is not a D flip-flop. It looks like a D flip-flop, but in this circuit, in the software, this is a counter and this is a decoder. Okay, so both are actually a 4-bit ring counter. So how it operates, I have talked about that. In ring counter, one of the important thing is that at a given time or at a certain time, only one of the flip-flop outputs or register outputs would be 1. So it may be T0 and rest of them will be 0. Okay, so it may be T2 is equals to 1 and rest of them will be 0. It is something like this, and it will be shifting with the emerging of every new clock pulses. And same goes for this 2-bit counter technique, decoder technique. It will work in the same manner. You will be seeing that the shift of logic 1 from T0 to T3 and coming back to T0 again. So it will work like a simple traffic light system. If you think about it, let me give you a view of this thing right here. So this both are the same circuit actually. Let me show you actually the working principle of it. So first of all, let me make one of the, can you see the thumb pointer? Can you see the hand gesture of my mouse?
Yes, sir.
Okay, so these are the outputs. These LEDs are the outputs. So these LEDs are the outputs. So this is the shift register technique and this is the counter decoder technique. Okay, so first of all, I would like to tell you one of the thing, that is we need to make one of the outputs to be 1 at the beginning. Okay, so for that purpose, what I'm doing, see that this is a D flip-flop with set and preset, set and reset, clear, or preset and clear. So I'm just using the preset to make this logic 1. So see that I have made 1 only logic. Okay, so right now what I'm going to do is I'm just going to give some clock pulses and see that what happens. It will just travel from this point to this point and then this point to this point and then this point to, so it will be traveling towards the right and coming back to the first point again. So this will be your ring counter. It is moving in circle or moving in ring. Okay, so see that. So can you see that it has moved in 1 clock pulse? Okay, so for the next clock pulse, so see that for the next clock pulse, it moves again towards the right, and for the next clock pulse, see that it moves again towards the right. And now it will, if I give another clock pulse, what will happen? This will turn off. This one will get into this this flip-flop right here. Okay, let me see. So see that. Can you see? So how it is working? Can you see? So it is, I have given the LED lights to actually make a replica of a simple traffic light system right here. You understand how a ring counter works? It is moving in circle or it is moving in ring. Do you understand? এটা কি বোঝা যাচ্ছে?
Yes, sir.
Okay, thank you. So this was our ring counter. Now let's talk about Johnson counter. So what is a Johnson counter? Basically, a Johnson counter is nothing but when you, so see that for a ring counter, what we did is, this was the example. So if we make it with a shift register, the last output was connected with the input. So if we want to make it a switch tail ring counter, the last output's complement will be connected to the input. So that will be called as switch tail ring counter. But the problem with that is the switch tail ring counter is, see that for a ring counter, we can easily say that it has only 4 states. You can easily see one of them is only 1 at a given time. So it has only 4 different states. Okay, only 4 different states for a 4-bit ring counter. Now for us a switch tail ring counter, so see that if I'm going to make a switch tail ring counter, what happens is, so let me delete this. So now it becomes now. So first of all, I'm not changing the below one, just to show you the output of the first one for the top circuit. Now this has become a switch tail ring counter. So I have connected the output of the output's complement of the last flip flop to the input of the first flip flop. See that what happens now? What will be happening? You see that there is only logic 1 at a given time at a single register. But now see what happens. If I give a clock pulse, see that multiple number of LEDs turn on. Can you see? So multiple number of register will contain logic 1. Can you see? For this switch tail ring counter. And see what is happening is a very beautiful thing. It's sort of like wedding light, biye bari light er moto dekhen, right? Can you see the top circuit switch tail ring counter, guys?
Yes, sir.
So the problem with the switch tail ring counter is, see that right now it is very difficult for us to find out a what you say, find out how many states are there. Okay, it is difficult. And because you cannot differentiate the states. Sometimes one is lighting up, so one register has only one value. Sometimes all of the registers are having one values. So this is the problem. So in order to make a certain number of states, what we are going to do is so first of all we make a switch tail ring counter. Then to differentiate the states, we are going to use decoder.